duplicates
Mhm.
in X. So you look at all the X values and you notice that there's a duplicate there and a duplicate there and there. And that's the first thing you're looking for. Then the second thing here is if you're looking to see like, do they go to the same value
Yeah.
or not, and why? Okay, and you can see that like, for example, 4, it goes to -2 and it also goes to 2. 1 goes to -1 and also goes to 1. This is bad. This is very
Mhm.
bad. This means that it is not a function. So it's not the fact that there are duplicates in X, it's the fact that they go to different values. So what you look for are the duplicates. Um,
What
so
does
this
number two
is
say?
same value or not in the Y. It's like does the X go to one or more Y values?
Mm.
So you should come up with your own words that you like there, but same, like if it was 4 -2 and 4 -2 down here, that would be okay. It's because they're different.
Okay.
That's the problem. You don't know whether it goes to 2 or -2. We can make like examples in real life of this that are more, I don't know, probably better than the numbers, but um,
So it's not a
it's
function because they go to different y values.
yes. And so the definitions for the same input, there are two different outputs,
Okay.
and that's bad. That's really bad.
Hmm.
So that's part A. Part B is the domain, which you can still have. You can always have a domain. The domain is the set of X values. They typically want them in increasing order here. So we're just looking at the X values now. 0, 1, 4, and 9. Usually this set notation is taught. If you're not using set notation, please say so. We can try something else. This is the most common notation.
So the domain is just the x values, like from least to
Yes,
greatest.
usually
Okay.
least to greatest. Usually you can get away with not putting them in least to greatest, but you also don't need any. You don't need to double up. Like if there's more than one, 4, you just put 1 in. So that's
Okay.
part B. Part C is the range. That's the Y values. Again, if you can, it's best to put it in kind of a increasing order. So you're just scanning the data to look for these. There's no metric on like how big or small they should be
Hmm.
or how many numbers. There's just, it is, you get what you get.
So range is just the y values.
Yep. So the
Okay.
domain is X. You think of it as X values, range of the Y values.
Sweet.
All right, are we going to 298 or 297?
We are going to 298.
Yeah, okay. All right, so same thing. You're looking for, to determine whether it's a function, you're looking for duplicates and are any of the X values duplicated?
Mm, no.
So there's no duplicates, which means that this is a function. Okay, every X value goes to a unique Y value.
Hmm. And then for B, determine or find the domain.
Domain will be the X values with no repeats needed. So um, Sometimes teachers want X such that X is an element of the real numbers, comma, X is an element of the set. And then you give it like there's sometimes more formal notation needed.
Hmm.
I don't get the sense that you're being asked for that, but
Yeah, I don't think we're doing that.
okay. So just keep it super simple here and do it like that.
Cool, got that.
C is the range. -27, -8, -1, 0, 1, 8, and 27. This is a common test question to get something like this.
Sweet. And then we're going to 308. So let me send over that picture.
Okay. Got that. Just uploading it now. You said 308?
Yes, do it, do it.
Okay. All right. It's amazing your book goes up this many problems. It's an oddity.
Hmm.
All right. So you're just evaluating functions here. One of the things that I like to show students that really could help you here is to imagine the variable is already in parentheses like that. So when you find f of 2, and it applies more so to negative numbers, but it shows clearly that you're going to first multiply and then add.
Hmm. So, and then f of x is just y, right?
It is y. Yeah, they're using this function notation, but you can think of it as y. The next one is f of -1. You want to again treat that variable like it's in parentheses, multiply before you add. The last one's maybe the most confusing because there's not much to do. You're just literally putting that variable in or that letter in for x, and there's nothing to do. You just put it in for x and stop. Um, you'll see further down the page, there's sometimes more to do, x plus 2 or h squared, but
So for
um,
c, I just replace the x with the a.
yes, yes,
Okay,
replace x with a, yeah.
let me just jot that down.
Okay, what's the next one to look at?
Sorry, one sec. It is 309.
Guess we're going in order. Not much different on this one. We
Yeah.
should do one with a square. Maybe that'll be coming up here. But again, like I would recommend writing it so that the variable is in parentheses, just the variable, nothing else. So then when you find f of 2, this is -4 times 2 plus 2, -8 plus 2, which is -6. That negative in parentheses really matters more for this one. Get your signs right.
Sweet. And then we're just going on in order till 320.
Okay. Is there any way we could switch, go to 311 or is that, well, why don't you do 310 on
But
your own and then we'll go
yeah,
to 311.
yeah, no, I see what you mean. Let's do 311.
Okay.
Since we're short on time.
This is where it's a little bit different in terms of the calculation if you don't do it the way I'm suggesting, which is just the variable in parentheses.
Mm-hmm.
Everything else is the same. And it won't matter for the positive numbers, but it will for the negatives. Okay, so it's 2 squared minus 2 plus 3, 4 minus 2 plus 3 is 5. For the negative one, this is where it's really important to get those signs right. And there's some confusion sometimes about what this actually means. You're squaring the whole number -1. It's -1 times itself, which is 1. Double negative, even with the parentheses, becomes +1, +3.
Mm-hmm.
For the A, it doesn't really matter. It's kind of like a positive number. It will matter more when it's an expression, but it just replaces the X.
Okay, sweet.
Yeah, we'll just go on to 312, which is similar. Or if we can, I mean, I'd like to get into the 315s. I don't know if you're comfortable moving that far ahead, but that would be worth
Yeah, for
showing you.
sure. Yeah, let's do that.
Or maybe let me do the 316 because you don't have that in the back of the book. Is that okay?
Mm-hmm.
Okay. So 316 here, g of x equals 5x minus 8. I'll do this parentheses thing again. So g of h squared means to put h squared in for x. Wherever you see an x, you just replace it. There's nothing to do except to drop the parentheses. You can't multiply. There's nothing to square. It's just like that. But maybe in another problem, next part B, that's part A, part B, we'll see something different. So g of x plus 2 means to replace x with x plus 2. And this time there is something to do. You can distribute the 5 to both. Minus 8 like that. So it ends up being 5x plus 2.
Plus 10. 5x plus 2. Mm,
Let me know if there's any
so
questions on that.
with the h squared, you're just kind of keeping the h squared, like you're not really.
You're replacing x with h squared.
Oh, okay. And
There's
then
nothing,
just yeah, nothing else changes.
nothing else changes.
Okay, sweet. And then oh, okay, got it.
Take a look at part
Interesting.
B before we go to C.
Yeah, that makes sense. I mean, we're just kind of distributing, so is the only real thing, real change. Oh wait, does the G distribute to the x plus 2 as well?
No, it's just
Just the
the
5?
here's the 5, yeah.
Okay, sweet. So,
So part C is G of X plus G of 2.
mhm.
So we should
Would
do
I
the,
just
go ahead.
write that whole thing in parentheses, like where the x should be?
Well, this whole part is the 5x minus 8. But then the G of 2 you kind of have to do off to the side. That's the 5 times 2 minus 8.
The gx
But
plus
for yeah, like they're
just the
separate
gx or
things.
okay.
The G of X is 5x minus 8.
How would I know that? Like, if I just saw a problem?
Just practice, just seeing
Okay.
that they're separate things. Yeah. So G of 2 you
Oh, okay,
calculate
okay, okay.
like we did before. You have to put the number in for X. Ends up being 10 minus 8, which is 2.
So wait, sorry, I'm just trying to plus g g2 x plus 10 minus 8.
So it ends up being 5x minus 8 plus 2, which is 5x minus 6. You're taking the result from G of 2
Oh, how
and
did
adding it to 5x minus 8.
how did you know that g times 2 is equal to all that?
No, G of 2, G of 2, because
Wait,
the
g
function is given. The function is given as 5x minus 8. And you put 2 in for X. Like part C is really two problems. It's taking the original G of X and adding to it the output of G of 2.
mhm. Okay. Let me get that written down.
Okay. Um, after this, let's move on to the next one. Be right back here. We'll try and get one more in.
Yeah.
So let's do 317, or actually let's do 318. You'll have 317 in the back of the book. It's the same sort of path here.
Let me
Kind
see.
of a very much a repeat of the last one, but part A is G of H squared minus 8 times H squared plus 2 minus 8H squared plus 2, like that. And then part B is G of X plus 2. You're putting that in again, wherever you see an X. So it literally replaces X, even though it's more than just X, and that's okay. minus 8x minus 16 plus 2. And then part C is the most complicated. It's saying take g of x. I should have done this in different colors and add to it g of 2. Okay, so g of x is the original thing you started with. G of 2 is kind of coming off to the side and evaluating it at 2.
G of 2. Two is equal to negative 8. Okay.
So that part is minus 14. You're adding it to the other here, so it becomes minus 8x minus 12, like that. All right. We do unfortunately have to stop there. I know there's more to cover, but these lessons do